The Cenozoic era geologic processes, 70 million years ago present. The Cenozoic era is the most recent of the geologic eras. The tectonic and volcanic activities that took place in this era have an important effect in the making of the present-day landmass of Ethiopia and the Horn of Africa. The land was subjected to two major geologic events and other geologic processes of lesser magnitude but still important. These geologic activities are a. Uplifting of the Arabo-Ethiopian landmass and outpouring of huge quantity of lava. b. Formation of the Rift Valley. Circa. Quaternary volcanism and deposition. Uplifting of the Arabo-Ethiopian landmass and outpouring of lava flood. The uplifting of the whole of the Arabo-Ethiopian landmass is a continuation of the slow rise that began in the Upper Jurassic and Cretaceous periods. This huge uplift continued to the Paleocene and Oligocene epoch of the Tertiary period. Where the uplifting was of greater magnitude, the land was pushed up to a maximum height of 2,000 meters above sea level. This occurred during the Eocene epoch. This uplifting was of an epeirogenic character. It was unparalleled anywhere else except in the alpine orogenic belts of the Andes. The whole of the Arabo-Ethiopian landmass was pushed up in blocks as one mass. The greatest uplift was in central Ethiopia. This immense tectonic force also fractured the crust at many places. Huge quantity of lava came out through these fractures. The outpouring of this flood of basalt spread widely and extensively and covered a large part of the Mesozoic sedimentary layer to form the Ethiopian plateau surface and also the floor of the present-day Rift Valley. At that time the Rift Valley was not yet formed. The mass of lava was so immense that it formed a thick layer of volcanic rocks on the plateau, which mounted to more than 1,000 meters above sea level in the north-central highlands. Where the lava comes out through vents, huge volcanic rocks were piled up to form many and huge volcanic mountains towering the flat basaltic plateau. This volcanic material is known as trapene lava or trap series lava. Where it is not dissected by erosion, the Ethiopian plateau had flat and nearly horizontal surface. This is an expression of the penaplaned Precambrian surfaces, the smothering effect of the Mesozoic deposition, and the spreading of the trap series lava over the Mesozoic sediments. The formation of the Rift Valley. The formation of the Rift Valley is said to be related with the theory of plate tectonics. According to the theory, the Rift Valley may be lying on the Earth's crust below which lateral movement of the crust in opposite directions producing tensional forces that caused parallel fractures or faults on the sides of the uparched swell. As tension widened the fractures, the central part of the landmass collapsed to form an extensive structural depression known as the Rift Valley, Figure 2.2. Figure 2.2. The Ethiopian and East African Rift Valley Systems. Source: Africa Map Library. The major faulting movement probably began in the late Oligocene and Miocene epochs of the Cenozoic era. This rifted the Red Sea Trough, which began to be flooded from the north. But the major rifting, affecting the whole African rift system, including that of Ethiopia and the Gulf of Aden, took place in the Miocene epoch. Rifting and faulting, however, continued all the time throughout the Pliocene and even the Pleistocene epochs. The Red Sea and the Gulf of Aden were connected as a result of the rifting and faulting of the land bridge that separated them. At the same period Pliocene, the Afar Depression, including the Gulf of Zula, was down-faulted allowing the Red Sea water to penetrate far inside. Reversed tilting and volcanic activity, later Pleistocene, blocked the connection and isolated the extension of the sea, allowing much of the water to evaporate. As a result, thick saline materials accumulated. During the same period, the area between the Danakil Depression and the Red Sea was uplifted to form the Afar Block Mountains. The spatial extent of the Rift Valley. The Ethiopian Rift Valley is part of the Great East African Rift System that extends from Palestine-Jordan in the north to Malawi-Mozambique in the south, for a distance of about 7,200 kilometers. Of these, 5,600 kilometers is in Africa, and 1,700 kilometers in Eritrea and Ethiopia. On land, the widest part of the Rift Valley is the Afar Triangle, 200–300 kilometers. The Red Sea, the Gulf of Aden, and the East African system meet and form the triangular depression of the Afar, where the Khobar Sink lies about 125 meters below sea level. The formation of the Gulf of Aden and the separation of the Arabian Peninsula from the Horn of Africa also took place during the Tertiary period. The Rift Valley region of Ethiopia is the most unstable part of the country. There are numerous hot springs, fumaroles, active volcanoes, geysers, and frequent earthquakes. The formation of the Rift Valley has the following structural, physiographic effects. It divides the Ethiopian plateau into two. It separates the Arabian landmass from African landmass. It causes the formation of the Dead Sea, Red Sea and the Gulf of Aden troughs. It creates basins and fault depressions on which the Rift Valley lakes are formed. Faulting and graben formation are not only limited to the Rift Valley. For example, similar tectonics activities have occurred in the Lake Tana basin. However, the formation of Lake Tana had been accentuated by volcanic activity, so that lava flow in the southeast had dammed part of the rim to deepen the basin. Faulting in other places had a structural control along some part of the river courses. Quaternary volcanic eruptions and depositions. They are recent volcanic activities that took place after the formation of the Rift Valley. This occurred in the Pliocene-Pleistocene epochs. This is a continuation of the tectonic and volcanic processes that earlier affected the Rift Valley formation. It occurred in the form of renewed rifting, faulting and more volcanism. This activity was generally limited to the floor of the Rift Valley and the region south of Lake Tana, where the lava covers an area of more than 3,000 square kilometers. Aden volcanics and recent faulting are more extensively developed in the Afar region. The area is shattered by numerous faults and subjected to extensive scoriaceous basalt eruptions. The latter phenomenon is also widely manifested in the main Ethiopian rift, especially in its northern section. Some of the eruptions have occurred in the last few hundred years. Of their recent occurrence, the Aden volcanics have relatively well-preserved and visible morphological features. The basic volcanic features of the Aden series include the following. Numerous and freshly preserved volcanic cones, many of which have explosive craters. Some of these are active dubi, Erta Ale, Afrera etc. Of these, Erta Ale is the most active volcano in Ethiopia. Volcanic hills and mountains, some of which are semi-dormant: Fantail, Boseti Guda near Adama, Alatu north of Lake Zaway, Chebi north of Lake Hawassa etc. Extensive lava fields and lava sheets, some of which are very recent. Lava ridges, thermal springs, fumaroles etc. Quaternary deposition. During the Quaternary period of the Cenozoic era, the Earth experienced a marked climatic change, where warmer and dry periods were alternating with cooler and wet periods. This was the time of the last Ice Age, in the middle and high latitude areas, and the time of the pluvial rains, in Africa. The heavy pluvial rains eroded the Ethiopian plateau, and the eroded materials were deposited in the Rift Valley lakes. The excessive rain resulted in an excessive surface flow. Rivers were many and large. They carried a lot of water and sediments. Lake and marshy areas became numerous and deep. Many were enlarged and covered much area and even merged together. For example, Zaway Langano Shala, Hawassa Shallow, Chamo Abaya, and Lake Abe and the nearby smaller lakes and marsh basins formed huge lakes. After the pluvial rains, the Earth's climate became warmer and drier. Thus, it increased the rate of evaporation that diminished the sizes of the lakes. Today, there are lacustrine deposits of continental origin around many of the Ethiopian lakes, river valleys and lowlands. According to the place and manner of deposition and depositing agents, these deposits are divided as follow. A. Lacustrine deposits. Deposits on former lakebeds and swampy depressions. B. Fluvial deposits. Deposits on the banks of rivers, floodplains both in plateau, foothills, etc. Circa. Glaciofluvial deposits and erosional features. These are occurred on high mountains, such as Bale and Kaka Mountains. D. Aeolian deposits, or windblown deposits. E. Coastal and marine deposits. Deposits on sea-invaded and sea-covered places. Porphyry deposits are mainly found in the Rift Valley, Afar Lakes region, Barrow lowlands, southern Barrena, and parts of northwestern lowlands. Generally, the Cenozoic rocks cover 50% of the land mass of the country. These include highland tertiary volcanics, basalts tertiary as well as quaternary volcanics, and sediments of the Rift Valley. 2.5. Rock and mineral resources of Ethiopia. The occurrence of metallic minerals in Ethiopia is associated with the Precambrian rocks. Although not in sufficient concentration and extent, a great variety of such minerals occur in the basement rocks. These rocks contain most of the metallic deposits known at present. The exploitation and search for mineral deposits in Ethiopia has been taking place for the past 2,000 years or so, and its early cultures were based partially on the mineral wealth of the day. Such has been the case of gold production and utilization, which has become part of Ethiopia's history, tradition and folklore. The mining and working of iron for the manufacture of tools, utensils and weapons, and the use of salt and salt bar, all these indicate to a fairly long mining tradition. However, presently mineral production from Ethiopia has been negligible by world standards. 2.5.1. Brief facts and current state of main minerals in Ethiopia. Geological surveys prove that Ethiopia has abundant mineral resources of metals and precious metals, coal, and industrial minerals. Gold. Gold has been mined in Ethiopia for quite long time, mainly from Benishangul Gumuz, Mekelle, and Adola. Operating mines produce gold from primary sources in such localities as Dermi Dama, Socorro and Lega Dembi. Mechanized alluvial working is confined to the state-operated gold field of Adola. Secondary gold deposits are common in the following localities: Adola, Murmur Basin, Shakizo, Awata Basin, Dawa Basin, Gainal Basin, Ujima Basin, Makanisa, Guba and Wambara Kafa. In Gambela and Ilyabera, Akobo River, in Saitama, Wando, Barrena, Nagel Yabalo area, and in Benishangul Gumuz, Shirkol, West Welega, Mengi Tumat Shengil areas to the Sudanese border, and the drainage of the Dedessa and Berber. Platinum. The Ubdo area in Welega is the only active Ethiopian platinum mine. Platinum occurrences have been reported from Dalati in Welega, and the valley of Demi Denisa and Bone rivers as well as Tulu mountain area in Saitama. Tantalum. Significant deposit of tantalum and niobium is found in southern Ethiopia. It occurs in Adola area where Kentika tantalum mine with resources of more than 17,000 metric tons of world-class ore reserve is found. The sedimentary and volcanic rock activities are also resourceful. Extensive lignite deposits in Ethiopia are found in Nejo, Welega, and in small amounts in Chilga, Gondar, are found in the sedimentary formations laid in between trapene lava. However, important lignite, one of the lowest ranked coal, is known to occur in many localities such as in the Barasa Valley, Andankober, North Shewa, Soyulta, Naradas Ababa, Mugur Valley, West Shewa, Alatu Valley, near Nejo, Karaso and Selmi Valleys, Debrelabanos, Zega Wodum Gorge, near Fish, Dedessa Valley, southwest of Nakempt, Kindo and Chale Valley, Omo Confluence, Adola, Wachal, north of Desi, Chuga area, on Gondar Meetma Road, Desi area, near Burkina River. The areas are promised to be a good prospect to meet some of the local industrial and domestic needs. Gemstones. Gemstones, including amethyst, aquamarine, emerald, garnet, opal, peridot, sapphire, and tourmaline occur in many parts of Ethiopia, mainly in Amhara and Oromia regional states. Quality opal was first discovered by local people in Wadla and Dalantawaredas, North Welloin Amhara regional state. Potash. Potash reserve in the Danakil Dalol Depression of the Afar region is believed to be significant. Gypsum and anhydrite. A limited amount of gypsum is produced for domestic consumption in Ethiopia, mainly for the cement industry, but very large deposits are known to occur in sedimentary formations of the Red Sea coastal area, Danakil Depression, Ogaden, Shewa, Goijam, Tigray, and Hararg. Total reserves are probably enormous because the thickness of the gypsum deposits is many hundreds of meters and the formation are known to extend laterally for hundreds of kilometers. Clay. Ethiopia is endowed with industrial clay material. Alluvial clay deposits for bricks and tile, pottery and pipe industry occur in Adola, Abay Gorge, and the Rift Valley Lakes region. Ceramic clay for the production of glasses, plates, bricks is found at Ambo and Adola. Tabor ceramic industry in Hawassa gets most of its raw materials from local sources. Marble. Crystalline limestone is widespread in the basement rocks of Ethiopia. Marble has been quarried in such localities as west of Mekelle and south of Adwa in Tigray. In the east in Galeti, Soka, Ramis, Rochelle, Kumi and other valleys of Shershay Mountain in West Hararg. In western also in areas built of Precambrian schist in Gondar, and the Dabas River and other neighboring river basins in Benishangul Gumuz and Goijam. Construction stones. Basalt, granite, limestone and sandstone are important building stones. For the surfacing of roads and compaction, basalt, scoria and other volcanic rocks are extensively used. Mesozoic limestone is an important raw material for cement and chalk production. The earlier cement works at Dire Dawa and the recent ones at Mugur Valley, Abay Gorge Dijan Tigray, Mesabo, are using similar raw materials from these rock formations. 2.5.2 Mineral potential sites of Ethiopia. According to the Ethiopian Geological Survey, the geologic formations that host most mineral potentials of Ethiopia includes 3 major greenstone belts and other formations, figure 2.3. These are 1. The western and southwestern greenstone belt. They contain various minerals. Primary gold occurrences Dul, Tulu Cape, Oda Goder, Akobo, Baruda, Bekuji Modish and Kalaj, Yubdo Platinum. Base metals of Azaliakandeu, Abetsalo and Kata, Fakushu molybdenite and the iron deposits of Baikalal, Chago, Gordana and Kor, Benshagil Gumuz marble, Akobo and Asosa placer gold deposits and etc. 2. The Southern Greenstone Belt. It is known as the Adola Belt, which comprises the primary gold deposits and occurrences of Lega Dembi, Sakaro, Welina, Kumudu, Megado Serdo, Dawa Dagadi, Moyale and Ababa River, the Colombo Tantalite of Kentika and Melika, and the Adola nickel deposit and other industrial minerals. 3. The Northern Greenstone Belt Tigray. This belt comprises of the primary gold occurrences of Terakemti, Adi Zirzane, and Nirig, the base metals of Turar, Sayathiemba and other parts of Tigray, placer gold occurrences of Tigray. Review questions. Answer the following questions briefly. 1. What were the major geologic processes of the Precambrian and Paleozoic eras in the Horn of Africa? 2. Explain the formation of the oldest sedimentary rocks in Ethiopia and the Horn. 3. Discuss the major geologic events of Ethiopia that took place during the Cenozoic era. 4. Where are the major mineral potential sites of Ethiopia? Discuss each of them with the help of examples. Chapter 3. The topography of Ethiopia and the Horn 3.1. Introduction. The topography of Ethiopia is largely determined by the geologic activities of the Cenozoic era. The uplifting of the Arabo-Ethiopian swell and the subsequent outpouring, spreading and thick accumulation of trapene lava have given rise to an outward-sloping highland plateau and mountains. Major faulting resulted in the division of the plateau into two broad units and the formation of a great structural valley. Faulting elsewhere and on the floor guided part of the course of some rivers. They also formed depressions on which lakes were subsequently created. Geomorphic processes brought some modification to the structural landform by river dissection and roughening on the highlands, and deposition on the lower areas. At the end of this chapter, the learners will be able to describe the topography of Ethiopia and the Horn, identify the physiographic divisions of Ethiopia, elucidate the physiographic characteristics of the Rift Valley, explain the impacts of relief on biophysical and socioeconomic conditions, general characteristics of the Ethiopian physiography. The Ethiopian landform is characterized by great diversity. There are flat-topped plateaus, high and rugged mountains, deep river gorges and vast plains. Altitude ranges from 125 meters below sea level, Kobar Sink, to the highest mountain in Ethiopia, Mount Ras Dashen, 4,620 meters. A.S.L., which is the fourth highest mountain in Africa. Ethiopia has the largest proportion of elevated landmass in the African continent. It is sometimes described as the roof of East Africa because of its height and large area. More than 90% of the Ethiopian landmass is above 1,000 meters of elevation, and above 1,500 meters makes 44% of the country. Half of this, in turn, is at more than 2,000 meters above sea level. Most of the Ethiopian highlands are part of central and northern Ethiopia, and its northernmost portion extends into Eritrea. The highland core, on the other hand, is encircled by semi-arid and lowlands. The Ethiopian highlands are rugged mass of mountains, situated in the Horn of Africa. They are the most significant physical features of the country, which form the largest continuous area of its elevation in the continent. They have been dissected by several rivers and ravines which have cut deep gorges. They have been divided into several regions and mountain systems. Most of the country consists of high plateau and mountain ranges that are sources of many rivers and streams that made the country to be described as the water tower of East Africa. The diversity in topography is accompanied by differences in other natural features such as soil, climate, vegetation and wildlife. Likewise, the socio-cultural and economic phenomena are also affected by the topography. Taking the 1,000 meters contour line for the highland-lowland demarcation, one observes the following contrasting features between the Ethiopian highlands and lowlands. Characteristics of Ethiopian highlands. Moderate and high amount of rainfall greater than 600 millimeters per year. Lower mean annual temperature, less than 200 C. The climate is favorable for biotic life. Rain-fed agriculture is possible. Free from tropical diseases. Attractive for human habitation and densely settled. The cumulative effect of all this is that the highlands have been significant throughout Ethiopian history in the economic, cultural and political life of the people. These highlands make up nearly 56% of the area of the Ethiopia. This is further subdivided into Lower Highland, 1,000–2,000 m. A. S. L, which make up 35% and Higher Highland, greater than 2,000 meters. A. S. L constituting nearly 22%. In contrast,